We just derived the integral form of a particular regularized incomplete beta function, but we're going to resolve this a little bit more. So I'm simply going to take this result and we're going to move it over here to this side and work with it a bit more. But there's not much more left to do, just a few identities. But to start off, we need to evaluate the new upper and lower limits of integration. So the question is, what is w of t star, and then what is w of 0? Well, if we recall, w is simply v over v plus t squared. And this is a function of t. So when we replace t with t star, we simply get v of v plus t star squared. And when we replace t with 0, we simply get 1. So this is for t star, and this is for 0. We get 1, which allows us to rewrite this integral as negative beta of these two values from 1 to this upper limit of integration. And here's our integrand. So what we recognize is the connection between the cumulative distribution function of students' t distribution and the regularized incomplete beta function occurs when we make that substitution, w equals v over v plus t squared. But we're not done yet, because we need to do a little bit more with this lower limit of integration. So first of all, we want to simply add a term and then subtract it off, which is doing nothing to the formula, which we'll do now. So what we're going to do is we're going to go from 0 to 1 of the same integrand, and sorry if this is pedantic, but I kind of wanted this to be very complete. We're going to add from 1 to our upper limit of integration. And then we're going to simply subtract off the thing we added, which seems superfluous, but you know, but I'll show you in a second. It's actually quite useful. Now, we have some identities that we can use, but first we're going to simplify this out. We're going to get from 0 to this upper limit of integration. We've got that integrand still, and then we're going to subtract off this lower, or this term that we came up with. And now I'm going to bring in some definitions. The first is, so here are some definitions. The first is just the definition of the regularized incomplete beta function, and that's simply this. u a minus 1 times 1 u b minus 1 du. And then also this, which always equals 1. So these are just some handy definitions. You can look them up. In fact, there's one more definition that I want to introduce while I'm here, and that's that there's a symmetry. This function obeys a nice symmetry like this. There we go. So these are just a handful of identities involving this function. And what we recognize is we've got, indeed, a couple regularized incomplete beta functions right here. So we can rewrite this expression as negative I of v over v plus this guy, like this. And then we can also write this term here. If we remember from our definition, that second term is nothing other than 1. And if we distribute the negative through, we're going to get 1 minus I v plus t star squared of v over 2 and 1/2. And that suffices to show or to demonstrate precisely what we set out to show, which was, indeed, that area is equal to 1 minus this regularized incomplete beta function. And this, the derivation of this, is actually not too obvious, but here it is. We did it. And indeed, it's correct. So this is going to help us in the next section where we look at an analytical formula for that critical t value. Thank you.